Deb, would you like to introduce the Dharma?
Yes. Hello, everybody.
And
Hello, this is Professor Dharma Hagare from Western Sydney University. Dharma's been involved in wastewater projects and irrigation projects for many, many years, and he's been a mentor and a leader in the field of research and sharing information. So he's going to go through a 30-minute presentation today. You will have received his 3 papers that we forwarded through, which will support his presentation. So following his presentation, we'll get you to work in breakout groups and to discuss his areas, and then he'll move between the groups, and then we'll come back as a group and do a collective discussion. So we've also, anyone else we need to introduce? Basant?
I think Ricky and I and Jason, we met everyone there for 5 days. So we all know each other.
Yes.
And the other person is Judy. So I think we introduced her last time. But Judy and Dave are the key people for this training program. And also I would like to request everyone to please switch on your video so our interactions are much more personal, and that will be really good. Thank you.
Yeah, good to see your face.
So just think like we are meeting in Pune.
Only there is a computer monitor between you and us.
And I think the remaining workshops will please try to join 5 minutes before, so we can start at 10 o'clock exactly, and then we finish on time. So that will be really good. Okay, so please, Dharma, go ahead.
Yeah, okay. Okay, thanks. Thanks for our Debbie, and thanks, Vasant. Good to see you all. Unfortunately, I could not join Pune workshop. I think there was a bit of a miss from my side. So yeah, good to see you all today. So as per the program, I'm going to talk about wastewater treatment and recycling. I think I know some of you are into wastewater treatment. So I'm going to present a bit of information, but again, this is a big topic. I don't think we'll be able to cover everything. So I'll make a presentation. I also asked you guys to answer 2 questions on slido.com and also Go Soapbox. I think some of you have put in the responses there. So we'll look at those responses and discuss some of those things as we go along. So let me start the presentation. But again, if you got a question or if you want to ask me or us anything, please stop and ask the question. So you don't have to wait till the end of the presentation. Sometimes you get some of these questions when you're presenting something. It's good to sort of ask those questions in that particular moment. So let's this. Okay, so can everyone see the slides? Oh, good. Okay, thank you. So as I said, I'm going to talk about wastewater treatment and recycling, and particularly I'm focusing on recycling for agriculture. Now we have been working on this for the last 14 years. So far, we have graduated 2 PhD students on this topic. Now, currently, there are 4 PhD students working with us on this particular topic. We have a very strong collaboration within WSU and as well as internationally. I do work with quite a few universities in India now, with Indian Institute of Science, University of Agricultural Science, Bangalore, IHR, quite a few other universities. So as a part of that, we have got some dual degree programs going on at this stage. So we have the strong collaboration, strong research going on in this particular area. Now I put this particular this particular question is combining stormwater and wastewater in one collection pipe is a good idea. So I got some responses. So there were about 11 responses. Out of that, the majority said it's a separate collection system, and only one person thought it's good to combine. Probably I'll leave that there and talk about the bit on the collection, and then afterwards you'll be able to make up by yourself, what is the best way to go forward. So let me go back here. So now what really happens in most of the developed countries, we have got the wastewater collection system, a typical wastewater collection system, which includes a sewage system at the back of the house, which collects the wastewater from all over the laundry, kitchen, and toilets, and bathroom. So all that is collected together and then put into a sewage pipe, whereas the stormwater is collected through a drainage channel, which is typically in front of the house, and whereas the wastewater, which includes black water and the gray water, is collected at the back of the house. So this is what the typical the collection system is: the stormwater in front of the house and the wastewater at the back of the house. So what does that mean is you have a separate the collection system for stormwater and the wastewater. Now some of the Indian system I have seen. So here what happens is the wastewater is segregated into a black water and the gray water. Now the gray water is kind of combined with the stormwater. It goes to a stormwater system, and the black water goes to a sewage pit. I know some of the big cities they've got a very good UG system, underground drainage system. Through that both the gray water and the black water and the gray water both combined together and taken through a sewage collection system. But in quite a few in the peripheral areas of the cities, you have something like this. So where you got the gray water combined in the stormwater, and then you take it out through a stormwater channel. So this is what we call a combined system. So this is different to the separate system what we looked at earlier. So this is a kind of a combined system where the gray water, wastewater is combined with stormwater. Now there are some problems with this. First of all, the black water causes major pollution to the groundwater. We looked at some of the groundwater samples in Bangalore. The total nitrogen was something like 120, 140 milligram per liter. And typically total nitrogen in groundwater would be less than 1 milligram per liter. So that indicates that there's quite a bit of pollution occurring because of the black water disposal through the pit systems. And once you combine the gray water with the stormwater, it's difficult to treat. It becomes a large volume diluted wastewater, so it's not a good idea to treat a large volume diluted wastewater through a treatment system. It's going to be very expensive. It is inefficient too. And also, moreover, during the rainy season, there will be high flows. You will not be able to capture all those flows, and it will just go through the treatment system, and that can result in washout because most of the treatment systems have got a biological treatment system. So when there is a high flow comes, all the bacteria which are basically used to treat the wastewater will be washed out. So then you'll have to start the entire treatment system again, which becomes quite a bit of problem. So in the wastewater treatment, you have the primary treatment that is in the front, and the preliminary treatment. These two are basically the first part of the treatment system. And then you got the secondary treatment system, which mainly includes a biological treatment system. So here, this is the primary treatment, and this is the secondary treatment system. And then we also have an advanced treatment system. Now, quite a bit in Australia, we do have a lot of plants with advanced treatment systems. So where we have got a BNR process, biological nutrient removal process. Through that, we remove the nitrogen and phosphorus. And then finally, it gets polished using filtration process and disinfection process. So eventually the wastewater treated to a very good quality through this treatment system. So in a treatment system, you have both you can have a secondary treatment, or you can also have advanced treatment system. We also in Australia we also use intermittently decanted aerated lagoon. This is a biological nutrient removal system, and these are quite widely used now in Australia. So these are what are known as the mid-sized treatment systems. So you can have the bigger size extended aeration based active sludge process. But in the mid-size, we use this intermittently decanted aerated lagoon, particularly for biological nutrient removal. We've got one of those treatment plant very close to our university here, which is called Richmond Idle Wastewater Treatment Plant. So, which the wastewater from here is actually supplied to Western Sydney University, and Western Sydney University has got a large landscaping area, and we use this wastewater for irrigation in the university. Now the other one which has become quite popular nowadays is what is known as a membrane bioreactor, MBR. It's ideal for a small scale wastewater treatment system. It has got it is a kind of a package treatment plant. It can be sort of constructed in a very small footprint. And also it's quite widely used now for decentralized treatment systems. Now we have what are known as sewer mining projects. In the sewer mining projects, what happens is we we extract the water from the trunk sewer, and then treat it. And the treated wastewater is supplied for a particular purpose, like irrigation purpose, and the solids is put back into the sewer mining. The trunk sewer. So this is what you call a sewer mining treatment plant. So these can be used up to 10 million liter per day plants, and these are very ideal for reuse of wastewater, because you can establish this where you really want the wastewater, and then you can run it at a very, very low cost. We have got one of these plants in, this is also very close to our place here, Penantals. So they have got this membrane bioreactor in the middle of golf course. So what they do is they extract the wastewater from one of the close by trunks of it, treat it, and the treated wastewater is used to irrigate the entire golf course. And the best advantage for them is, their water supply is, secured, throughout the year, and any year as well. Because if there is a drought conditions here, generally we have restrictions. You can't use town water for irrigation purpose. But these guys won't get affected at all, so they can use that water even during the drought periods. So that's one of the advantages of using recycled water for irrigation purpose. So this is the schematic kind of a flow sheet. So you've got the biological reactor, and this effluent from here is filtered through a autofiltration membrane, and the solids put back into the biological reactor, and the treated effluent is taken out and treated for disinfection, and then afterwards it is disposed, used for irrigation purpose. So as I said, the treatment system can be very compact, and the footprint can be very, very small compared to many of the treatment plants, wastewater treatment plants. So just in the nutshell, I think membrane bioreactors are good. If you're looking at a small treatment plant, say 1 to 10 MLD. So if you're looking at intermittently decanted aerated lagoons, idle plants, they're good, for a size of 25 to 50 million liters per day. And if you've got large flows, then you need to go for aqueous process, which is a standard, the centralized treatment system for large flows. So you can use this as a kind of a thumb rule to sort of work out what is the treatment system you can possibly consider depending upon your source. So, but if you're looking at agriculture, the water use, the secondary treatment could be quite sufficient. So, we don't have to really go for advanced treatment or a tertiary treatment to use the wastewater for the agriculture purpose. That's the biggest advantage for reusing the water for agriculture. So if you use the treated wastewater for agriculture, so you can reduce the freshwater consumption, so that the freshwater consumption go into urban water supply system. So you can manage, that particular portion of the water demand for agriculture using recycled wastewater. And the recycled water has got some, nutrients. So that can be, the made use for for growing crops or keeping your garden green. And certainly in that sense, the use of recycled water makes sense. I think the first thing is you don't have to spend a lot of money on the treatment. So there are two options: the secondary treatment and the advanced treatment. The wastewater from both of them can be used for reuse in agriculture. And so we have done some work on what is the best between these two for agriculture use. So we sort of came with the conclusion that the MBR, the secondary treated wastewater, is pretty good for agriculture use. So whereas the idle one, that's the advanced treated wastewater is not as good, because what happens is there is accumulation of salt and not much nutrients as well. So that salt accumulation, particularly sodium accumulation, can result in a retarded growth of plants. So whatever the plants you're looking at. So in that way, they, the secondary treated, wastewater is the way to go if you're looking at, the wastewater reuse for agriculture purpose. There are quite a few, projects now in Australia, where we are using treated wastewater for various purposes. In urban areas, we use this treated wastewater for urban irrigation, which includes irrigation of the sports fields, parks, and also if you've got a forest land nearby. So this wastewater is used for all those irrigations. Nowadays, this blue-green infrastructure within the urban area is becoming a very important issue. Because through the blue-green infrastructure, you'll be able to control, the heating up through this urban heat island effect, especially during the heavy summers. So because of that, this the use of recycled water has become very, very important. We got another project, this is in Queensland, where what they do is they use the treated wastewater for irrigating some of the forested area, and where they harvest that forest for for the timber. So it's one of the good case studies which is being carried out for quite some time in Australia. Now, this is another one. I think a lot of you are familiar with this. I think this is a Bangalore Casey Valley. This is one of the large scale wastewater treatment, wastewater reuse for agriculture across the world now. So this is established with the 124-kilometer of pipeline. I think I got some here yet. So you can see that the amount of water coming out of this, the particular pipe is massive. So the wastewater from one of the treatment plants from Bangalore is pumped to Kolar district using 124-kilometer pipeline. So understand that this was a massive project which was constructed and implemented a few years back. So here, what they're doing is they are supplying the secondary treated wastewater to fill up all the tanks in the Kolar area. Now, what are the issues? So I put up this question on Slido.com. What problems would you anticipate if treated wastewater is directly used for irrigation crops? I think there are some very good answers which can be. Okay, so looks like the most of you have picked up the issues surrounding the use of the wastewater for irrigation purpose. Of course, the soil salinity is one of the important ones. Now, I think some of you might be aware the salinity actually comes from your cooking, particularly in the kitchen, and also people use some of these sodium-based cleaning agents. particularly in laundry and some of those. And that salt gets accumulated in the wastewater. So in the wastewater, you're looking at about 1,000 milligram per liter of salt, whereas in the tap water, you're looking at 100 to 200 milligram per liter. So there is an increased, the presence of, salt in the treated wastewater. So unfortunately, the salt is not removed in the, wastewater treatment plant because it's all in the dissolved form. So the whatever comes into the wastewater treatment plant in terms of salt, it basically just goes through. So there's no removal at all. So that salinity is one of the biggest issues with the use of recycled water for irrigation purpose. Of course, there are other issues like pathogen contaminants, and leaching of some of the material into the groundwater, and also some POPs. I don't know whether anybody picked up on those. Persistent organic pollutants. Now in Australia, we have got one of those persistent organic pollutants called PFAS. So now the PFAS has become a bit of an issue in terms of both use of the treated wastewater as well as biosolids. So there are lots of restrictions on where the treated wastewater can be used because of some of these persistent organic pollutants. And we looked at some of the the wastewater which is treated in India. So some of the treatment plants, the treated wastewater from some of the treatment plants have got heavy metals as well. Now there is some tendency of the heavy metals getting accumulated in the in the crops. Yeah, that's kind of a research which is still going on. So there are again I think there are some issues with use of the recycled water for agriculture purpose. I think we need to understand that. And we need to be aware of those. And in order to avoid those long-term issues, we need to have an appropriate treatment system before we use that wastewater for agriculture purpose. So now we do. There's quite a bit of literature. In fact, some of our students also working on this now. Now some of these heavy metals, there is the evidence of heavy metals getting accumulated in some of these crops. You can see that there's 118% increase, 166% increase of arsenic, and 80% increase of nickel. So there is the evidence of some of these heavy metals getting accumulated in the crops. So particularly heavy metals, we need to make sure that we remove those, before we supply the wastewater for agriculture purpose. Now, these are some of these POPs, which mainly comes from the pesticides, herbicides, and some of these chemicals which are used for agriculture purpose. And there again, there is these chemicals have been detected in soil and on the crops. Now, currently, we are doing quite a bit of work in PFAS now. So we have looked at some of the samples. So although there is no concluding evidence that PFAS gets accumulated in the crops or in the final food product, but there is accumulation in the soil and the plant material. So this needs to be further investigated. So what are the issues that you need to consider in the Indian context? I think the Indian context, I think one of the main issues is the collection system. So at this stage, the collection system is not fully developed. So you really need to have a kind of a separate system where you separate the stormwater from the wastewater, so that it's easy to treat the wastewater, and you'll be able to achieve a better treatment for the wastewater if you want to separate it. And also you need to have pre-treatment for the industrial wastewater. So any industry who wants to, to dispose the wastewater into the wastewater, the sewer system, they need to have a pre-treatment system. So they need to remove all the toxic materials and the heavy metals before putting the wastewater into the sewer system. I think that should be mandatory. And also you need to have appropriate pricing and the water policy. See, here what happens is, if somebody wants to use the wastewater for any purpose, their price is set around at 75% of the drinking water. So some kind of, the pricing has to be set, for in the Indian context. And huge investment is required in particularly in the collection system and the treatment system. I think some of you will be aware of this. Now, the centralized treatment system are not ideal for the wastewater reuse. I think for me, I think if you want to really have a good wastewater reuse, you should go for a decentralized treatment system. So which is because you'll be able to save a lot of money on the transmission of the treated wastewater to a desired location. So that would be the best way to manage. A bunch of decentralized treatment system would be very, very beneficial. So I think that's all I got, I suppose. Thanks very much for your attention. So I'm happy to take questions, if there are any. Hope it was useful.
Yes, sir, it was very useful, and we got to know about the various ideas also, which will be useful for Indian scenario.
Thank you.
Sir, sir, is it audible? Hello?
Yeah, we can hear you. A bit feeble,
Yes,
but
So if it is, if you use directly wastewater in for agriculture, will it be, because wasted treat water itself having lot of heavy metals issue? Because here in India, some places, some river full of wastewater is there, but however, the farmers are using groundwater basically. It is close to the river only, but they are cultivating crops based on groundwater. But there is a chance of contamination or something.
You mean after treatment or before treatment?
No, there is no treatment, sir. Directly they are using.
Without
Yes.
treatment, I think there could be heavy metal pollution issues. It's easy to remove the heavy metal in a treatment system. Any metal can be converted into metal hydroxide. So when it's converted into hydroxide, it gets precipitated. In a treatment plant, it's easy to remove the metals. It's not the big issue. But if you don't provide treatment, there could be some heavy metals. So that can create problems. And the heavy metals can be easily uptaken by the plants, and so that can get into the food chain. If it gets into the crops, it can easily get into the food chain. But some kind of treatment is very essential. If you want to reuse wastewater for agriculture purpose, so some kind of treatment is very useful, and it's always easy to remove the heavy metals. What is difficult to remove in the wastewater is these POPs, persistent organic pollutants.
Okay.
Some of the persistent organic pollutants will not be removed by the bacteria because they are very hard to degrade, and they will just go through some of the herbicides and pesticides. So those are the things which can end up in the treated wastewater. At this stage, we do not have a lot of data on how the POPs are uptaken by the plants. So that's where I think we need to do a bit more work on that. So hopefully we'll have a bit more understanding as we go along.
So
Hope that
is
answers your question.
Yes, sir. So is there a way to see visually whether that food crops is cultivated by some kind of wastewater or something? Because it looks like exactly uh, freshwater. Also, if you use and if you use wastewater also, you can see the same. Suppose carrot or some vegetables looks the same only. We are not able to find visually actually which water they use for cultivation.
Yeah. No, visually you can't. You need to do the chemical analysis and then look at what is there inside the crop.
Yes, sir.
So yeah, we need to do the chemical analysis. So, quite often you see the plants, you got these macronutrients, the NPK, yeah.
Yes,
So
sir.
so as far as they have got the macronutrients and some of the micronutrients, they grow well, and plus water. I think if you got all that, they grow well. But if you got some of these, the contaminants which are uptaken by the plants, their growth will not retard as such. So the only the worry is that the material getting into the food chain. So for that we really need to do the analysis and find out whether there are any the contaminants present in that food crop.
Thank you, sir.
Thank you.
Namaste, sir.
Yeah, sure. Reshma, go on.
Yes, sir. Yes, my name is Rishma Pillai from Hyderabad. Sir, actually, regarding this sock pits, actually in India right now, due to the government initiatives in many villages level, they are doing community sock pits as well as individual sock pits. And the issue regarding that is that they put the grey water, but nearby there will be borewell in a distance of below 5 meters. So, is there are any chances that can pollute the borewell water? Even though they are using gravel packing and everything, what can we do to tackle that issue? Or in sockpit, is it suggestible to put grey water and the other storm water? So can you just give some insight into that?
Oh yeah, definitely there is a very, very good chance of that the sewage contaminating the groundwater. If your borewell is located to one of those the blackwater pits. I remember we had some guidelines. The distance between the borewell and your septic tank pit should be minimum of 30 meters, but I'm not really sure whether that's still valid. So there are some guidelines. What should be the distance between your borewell and the soakage pits. But it all depends upon your soil conditions. If you got a sandy soil, I don't think 30 meter, even 100 meter will be good enough. So I think one has to look into what is the soil conditions, and based on that you need to decide. But at least in the urban areas, having a soakage pit and also the borewell in the same property, I don't think it's a good idea. Unless you establish some kind of a barrier between both of them. So that's that's one of those things that you need to be very, very careful. This is one of the reasons I think we have picked up some few samples in Bangalore, and your total nitrogen level is very high. something like 140 milligram per liter. So that's mainly because of these leaking, soakage pits, which are polluting the groundwater. So as far as possible, you need to maintain, a large offset between the soakage pit and the borewell. But given the land area, it's going to be very difficult in India. So that is why, what I think is you need to have good collection system. That's one of the way of avoiding this groundwater pollution. Hope that's useful.
Thank you, sir.
Okay, thank you. Thank you for that.
Just a comment on the groundwater pollution, Dharma.
देखिएगा मैं ऑफिस तो सोचेगा कि
Hello, Loic. Can you switch off your microphone? So groundwater pollution can be a serious problem, especially in urban areas due to the leakage in the sewage system. And also sometimes the wastewater just flows through the creek or river nearby. And in Udaipur city, we have found groundwater is very much highly polluted because of the wastewater contamination. And the other issue we need to think that once the groundwater is polluted, it takes a long time to make it better, especially the shallow groundwater. So we have to be very careful how we reuse wastewater and especially grey water. And we have done some study in Sydney area that it can affect the soil health. For example, if you use the grey water in the backyard for irrigating vegetables or some other trees or whatever, over time it can accumulate some salts or some other things. So it is good idea to use, but just need to keep eye on.
Salt accumulation is a big issue when you're using this. There is a question by Dheeraj Kumar Bagaria. Do you have any crop irrigated by wastewater, which is consumed by people in Australia, using only for commercial crops like timber? At this stage, it's only commercial crops. There is, the indirect, recycled water used for irrigation. So in the indirect, what happens is they pump the well-treated recycled water underground, and then they extract that groundwater and use it for both potable purpose and as well as the irrigation purpose. So that indirect recycling is going on in several places, particularly in South Australia and Western Australia. But at this stage, the direct usage for food crops is not there. So we are doing some work with Sydney Water on this now. But there are very, stringent guidelines on use of recycled water for food crops in Australia. So it will take a bit more time, before we use the recycled water for food crops.
Just to add on what Dharma said, on the Hawkesbury campus of Western Sydney University, we have been using not grey water but wastewater for last 30 years to irrigate pastures, lucerne, and that is fed to cattle or cows. And so when you come here, we will show you on the farm here how it is used. It's a big scheme, Hawkesbury water recycling scheme, where water is collected from Sydney Water's treatment plant, and then it's stored in number of dams, and then it is used for irrigating, especially pastures and lucerne.
Hello, sir.
Yep. Yeah.
Yes.
Amandeep.
So myself Amandeep Kaur and I'm a scientist in CGWB. Sir, actually, in this SEOIP, my study is to do the impact assessment of reuse of treated wastewater, which is being supplied from Bangalore city to the farmers in the Kolar district. So I want to know how I will proceed further for the impact assessment of this treated wastewater on the crops, because basically they are growing chickpeas, ragi, millets over there. So I want to do impact assessment of, can you guide me in that?
I think this is going to be a good project, if you're working on it, Amandeep. In fact, there was one student from US, Bangalore. So he is also collecting some data on this. So looking at the, the wastewater quality in all those tank burns, and they're relating that to the soil, the contaminants in the soil in the surrounding area. I guess it's probably in this case, what you need to do is you need to collect lots of analysis. So you need to look at the wastewater quality. You need to look at the soil quality. Whether there are some of the heavy metals or some POPs getting accumulated in the soil, and also you need to look at the crops. So you collect some of the crops, like maize or whatever grown in that area, and look at what kind of contaminants are there in those crops. So a systematic analysis of some of these crops, soil, and water. If you can get that data, so you'll be able to link it out and see if there is any correlation. I think that work will be really good if we can manage. But some of these parameters require quite an extensive analytical equipment. So you need something like the LCMS and some of these equipment to do the analysis. So if we are able to get those, get the access to those for doing those analysis, I think it will be a very good study.
And one more.
Yes. Amandeep, just two or three things I want to suggest to you.
Yes, sir.
One is maybe Dharma, if you could link Amandeep with the PhD student,
Yeah.
so she can get some extra data.
Mm.
And since Amandeep, your study is for, I think we have now 12 or 13 weeks left. So you can collect some secondary data. Then there are lots of studies have been done in Australia also, and India and some other places. So I think your task could be to identify what could be the impacts, and then contextualize in the case of Bangalore. So there is no shortage of studies. If you do a Google search or Scopus, you can find there have been quite a number of studies done, and I know a few of them, so I will share it with you.
Yeah, sure, sir.
Yeah, I think there is some work done at ISC Bangalore and also US Bangalore. To be able to get some, some papers from those two institutions. But
Okay,
anyway, you send us an email. Send me an email, so I'll send you some of the literature.
yeah, sure, sir. I will email you.
Yeah, sure.
Thank you, sir.
Thank you. Okay, so any other questions? There is another question here. Chandrai Day. Is there any study which gives an insight of how heavy metals are accumulating as we progress in the food chain? How is the public acceptance in Australia regarding usage of wastewater in the agriculture sector? I think in the first one, heavy metals accumulation, there is quite a bit of literature on heavy metals, but heavy metal accumulation occurs only when you use raw sewage. If you got some kind of treatment, heavy metal accumulation doesn't happen because most of the heavy metal get precipitated in the treatment plant. But there are some studies where they use the raw sewage for irrigating crops, and they found some accumulation. I think I presented some data there in my presentation, but there is quite a bit of data there. So you'll be able to get that from the literature. The second part of the public acceptance, see again, as I said, at this stage for food crops, it is only a indirect use of recycled water. There is no direct use at this stage, but I think this is going to change. So it will take a bit more time. It will, change as we go along. Hope
Thank you,
that
sir.
answers your
Thank you,
question.
sir. Yes, sir. Thank you.
Mhm.
Sir, in one of the papers, it is mentioned that the land which is not following this recycle water irrigation is more susceptible when it is applied when we introduce it newly. It will be more susceptible for salinity. So if we implement this in India, it will whether it will cause drastic salinity changes for the soil, increase in salinity.
Yeah, the salinity will occur if you're using the recycled water continuously. But what happens, I think one of the paper you'll be able to see, so you apply the wastewater during non-monsoon period. So in that time, the salt water gets, the salinity gets accumulated. But when there is a rain, so what happens is all that salt moves to a lower level of the ground. So because of that, there is a flushing effect. So because of the flushing effect, your salinity in the root zone will come down. So it, if you got a normal monsoon period, so it might, if you're using the recycled water for irrigation, so the salt can accumulate during the non-monsoon period. But when there is a monsoon period, all that salt can migrate to a lower level, and your salinity level will come down during in the root zone. So that's a possible scenario there. But this becomes a bit of an issue when you got a prolonged drought periods. So 4 to 5 years, if you don't get proper rain, then there is an increased accumulation. So if you keep continuing using the wastewater for irrigation, so there could be a severe increase in the salinity level. This did happen in Australia, in the Gosford area, where when we had around 2006, 2009, we had a prolonged drought. During that time, one of the area got highly saline, because of the continuous use of recycled water. But so as I said, I think if you get your monsoon rain regularly, so it should not be a big issue. But if it doesn't, then you will have to have some kind of intervention. So either use the fresh water for irrigation, or you don't use the recycled water for irrigation. Hope that helps.
Thank you, sir.
Okay, so any other questions? Good. I think some of the questions were really good. Yeah, thanks so much. And we had a very good discussion. So over to you, Debbie. I think you're going to make into breakout rooms now. You're muted.
Yes, I'm just trying to stop. I've been recording the presentation. I'm just going to stop that recording so we don't need that anymore. Our intention is that with the presentations by people like Dharma, we'll put them on our open learning site. So you can go back and refer to that information, plus also the papers and any other references that are available. Our intention was to have you work in breakout rooms for some discussion on the topics, and the breakout rooms are based on